This lesson is going to go over conditional probability a little bit more using a variety of different diagrams, including a two-way table, a Venn diagram, and a tree diagram. So there's some information here that tells us about these people that were asked whether they prefer chocolate or vanilla. We have a percentage of males that chose vanilla and then a number of females that chose chocolate. So I want you to take a second, pause the video. Based on just these 3 bullet points here, without going any farther, who do you think, what flavor do you think won, either chocolate or vanilla? And just take a minute, write a sentence. What out of these 3 bullet points makes you think that either chocolate or vanilla won? So now that you had a chance to take a guess, we're going to actually use those 3 bullet points to fill in this two-way table. So here you can see that the total number of females and the total number of males have already been filled in. So adding these two things together gives us a total of 14,766 people. So we're going to fill in the rest of this information here. So I know that 4,732 females chose chocolate, so I can put that here. 4,732. And if I subtract this number of females that liked chocolate from the total number of females, I can find out how many females chose vanilla, which would be 4,024. And then I'm going to have to use this percentage to determine how many men chose vanilla. So I'm going to take the total number of males, which was 6,010, and I'm going to multiply that number by that percentage as a decimal. And of course, my screen froze, which gives us a decimal value. But since this is people, we're going to round up. So I'm going to say 3,588 because we can't have a decimal of a person. That's not how it works. So that's the number of men that chose vanilla. So that number is going to go here. And then subtracting these two numbers is going to give me 2,422 that are choosing chocolate. And then I can add in the columns to see how many people chose chocolate and how many people chose vanilla. So 7,154 for chocolate and 7,612 for vanilla. So that's what that information would look like in a two-way table. Now here in my Venn diagram, you can see I have number of chocolate and number of female. So this would be chocolate versus female. So then the number of, now let me rewind a little bit. Let's talk about what each of these sections mean. So this overlap here is where it is both chocolate and female. Since this is outside of the chocolate circle, this would be female and vanilla. Since this is outside of the female circle, this would be male and chocolate. And then outside of both of those circles, not female and not chocolate, would be the males that chose vanilla. So that's what these numbers are going to represent. And now we're going to take those. I can take this information from my two-way table and put it into my Venn diagram. So my overlap is chocolate female. So that would be this rectangle here. So it would be 4,732. And then chocolate male, 2,422. And then male and vanilla. I'm going to move this out of my way a little bit. Male vanilla is 3,588. So that's what that information would look like in a Venn diagram. I could have done the same thing with vanilla and male or vanilla and female or chocolate and male. The numbers would look different because those circles would represent different things in my two-way table. But if you add all four of these numbers up, you would then get to the totals in here. So if I added up these two numbers, I would get the total male. If I added up these two numbers, I would get the total female. All right, so let's talk about this tree diagram. So you'll see here I have my male and female values. This is chocolate given that they are female. So they've chosen chocolate as their favorite given that they are female, which would be this space in my two-way table when my computer unfreezes. There we go. So you'll see chocolate given female. Now I have vanilla given female, so that would be this value here. So this would be 4,024. Now we're going to the male. So chocolate given male would be this cell here, 2,422. And vanilla given male is 3,588. All right. So now I need to figure out if chocolate or vanilla is going to win. So I'm going to do this on a separate sheet of paper. I do not have enough space. Write probabilities to support your claim for the flavor of ice cream. So we're going to do a couple different things here. The first thing I want to look at is some conditional probabilities. So let's look at male given that they're choosing chocolate. So in that case, I'm going to come back up here. We're choosing chocolate. That is the event that has happened. So this is going to be, I already have an equal sign. If you want to think about this in fractional sense first, this would be my chocolate total, and then my chocolate and male value. So my total chocolate would be 7,154. And the number of men that also chose chocolate is 2,422. that is about 33.86%. So let's do the same thing with female given they chose vanilla. So that would be vanilla and female over the vanilla total. And then we've got vanilla and female. It's 4,024. We make a value that actually looks like a 4. And then the total vanilla is 7,612. So if I divide that out, we've got about 52.86%. So now what if I flip these? What if I do chocolate given that they are a man? Well, that would be the male total over, or excuse me, that would be my denominator, would be the male total. And the numerator is still going to be chocolate and male. So my numerator is still the same, 2,422, but now my denominator is the total number of men that they asked in this survey. So if I divide that, that's 40.3% rounded. Which, if I did the complement of this, vanilla, given that they are male, it should give me this percentage here that we started with. I could also do vanilla given male. I could also do 1 minus chocolate given male because they are complements of each other. They add up to make 100%. So if I did 1 minus this as a decimal, 0.403, that actually gives me 0.597, which is 59.7%, which is what they gave us in my original bullet point, which is good. That's what we wanted to happen. Make sure all of our math in our two-way table is correct. Let's do one more. Let's do probability of vanilla given female, and we'll see how different that value is there. So my numerator is going to stay the same, vanilla and female, and my denominator is going to be the female total. So total number of females is 8,756, and then female and vanilla was 4,024. So when we divide that, we get rounding up to, actually, I'm going to do 2 decimal places. I can do 2 decimal places this time. Just under 46%. All right. Still doesn't totally answer our question if vanilla or chocolate is more. So, in order to answer question number 4, just to do a final solid answer to whether chocolate or vanilla is preferred, we're going to look at my total sample space and then total chocolate and total vanilla. So the probability that someone would choose chocolate is my total number of chocolate out of my total sample space. So 7,154 out of 14,766, which gives me, when I divide that, 48.45%. It's not looking good for chocolate. Now, vanilla should be the complement of this. It should be 100% minus 48.45%. We're going to do it with the probability fraction, and then we will double check it. So my total number of vanilla was 7,612. Already, based on the numerators, I can tell the vanilla total is more than the chocolate total. And since I'm comparing those to the total in my sample space, I know vanilla is going to win. Which gives me 51.55%. So if I did 100 minus 48.45, I actually do get 51.55%. So in this case, vanilla is in fact the winner. So sorry to all of my chocolate lovers, but in this case, vanilla was the winner. So if we talk about what's easier to see and use in some of these, for a tree diagram, we can see our events really well. And we can see our conditions as well. So if we think back to the tuberculosis task we did on Friday, not TB and positive, so getting a positive test but not having TB, it was really easy to find that number at the end of my tree diagram. One thing that's hard or hidden that we have to do some calculations is our totals. But in a two-way table, our totals are right there, easy to see. But sometimes it's harder to see these are kind of flip-flopped. Now, with a Venn diagram, if we look back at our chocolate versus female, it's really easy to see those conditions again. But again, our totals are sometimes hidden and we have to do more calculations to figure out the total number of females or the total number of people that like chocolate. One thing we have to consider is if we have enough information. So some things that we might need to consider when trying to figure out if this is enough information to say vanilla wins. When we look at our sample space, there's two questions we really need to ask ourselves. Was the sample space big enough? Is almost 15,000 people a big enough sample space? And we have to consider, is that sample space diverse enough? Is it enough to just ask men and women? Or is there other information that we might want to also consider when we look at that population that we're asking? In this case, would it matter if we were asking people in on the East Coast versus the West Coast, or in the North versus the South? So just considering the diversity in the sample space is also something to consider when we're trying to figure out if that's enough information to say vanilla is the winner.